In Module 3, Section 5, we talk about roots and rational exponents. For example, here we have the square root of 25. This symbol right here is called the radical, and the number underneath is the radicand. Now the answer to the square root of 25, most of you know, is 5. And the reason that is because 5 squared is 25. So the square root is really how we undo, it's called the inverse operations, how we undo squaring. Let's look at the next example. This is called the cube root. The cube root is where you ask yourself, what to the third power would equal 27? Of course, the answer would be 3, because 3 to the third is 27. Now, I mentioned briefly, the squaring and the square root actually undo one another. So when you square a square root, you just get the thing called the radicand. So this answer would be 25. The 2 and the square root cancel. Now in the next question, we have the cube root. However, we are cubing it. So when you cube a cube root, you get the radicand once again. They undo one another. They cancel. Here we have 6 different examples. You might want to pause the video and try to write down the answers to these 6, and then I'll go through them. All right, the first one, the answer would be 4, because the square root of 16 is 4, and that's because 4 squared is 16. The next one, the square root of 64 is 8, and then that minus sign is on the outside, so we have negative 8. Now on this problem, this would be a non-real answer, so we would write not real answer. There's a thing called unreal or not real numbers. They're called imaginary numbers, and that's because there is nothing that could square that would give negative 9. Anything times itself is going to be a positive, so there's no way we could make a negative 9. This one right here would be 0.9, because 9 times 9 is 81. On this one, you would square root the top, square root the bottom, and you get 8 over 11. On the last one, we have a square and a square root that cancels. You don't need a calculator on this. The answer is 12.7. Here we see the square root of 20. Now 20 is not a perfect square, so this does not come out to a nice plain number. So you go to your calculator and you see it has 4.4721359549999579. I'm looking at my iPhone and that's what it has, and then I run out. But we know it keeps going. Irrational numbers are non-repeating decimals. So they do just keep going. They're non-repeating, so you can't really necessarily predict what the next number is. It almost seems random, but it's not. But that's the answer there, and that's because 4.47 squared is about equal to 20. So if we were to take our answer and square it, we ought to get 20 right back. Of course, I did a little bit of rounding there, which is why I said approximately 20. I said earlier that you cannot have a negative radicand on a square root, however you can on a cube root, because the answer here would be negative 2, and that's because negative 2 times negative 2 times negative 2 is negative 8. So that's why we can have a negative square root on a cube root, or even a fifth or seventh, any odd root you can have one. This next one, we have the third root of a negative 64, so that would be negative 4, because negative 4 times negative 4 times negative 4 gives you negative 64. Now you have to ask yourself, what to the third power gives you x to the sixth? And we'd have to have an x squared in there, because 2 times 3 makes that 6, so 3 groups of 2. So the answer here is negative 4x squared. We can also have other roots. We can have the fourth root, for example, and we would have that down here. So we ask ourselves, what to the fourth power equals 625? And the answer is 5. And that's because 5 times 5 times 5 times 5, 4 of them, is 625. Now this may at first glance seem like completely different than what we've been talking about. We've been talking about radicals. These rational exponents mean fractional. But it turns out when you have a base a with a fraction of an exponent, in this case a numerator 1, the number on the bottom is actually a root. So this would be the nth root of a. So for example, let's look at the 25 to the 1/2 power. This would be the same thing as the second root, in other words, the square root of 25, which is 5. The next one here, 27 to the 1/3 power would be the third root of 27, which is, we've seen that problem already today, that's 3. And then going back to the very first problem there, we simply rewrite it as 5th root of x, I think is all that they wanted you to do there. And on this last one, this would be the same thing as the third root of negative 27 x to the 6th. So that's going to be negative 3 x squared. Remember on the previous slide, we saw that the third root of x to the 6th is x squared. Now you might wonder, what the heck happens if the numerator is not 1? Well, this bottom number is still your root. Roots are underground, after all, which are in the bottom of the fraction here. So that's one way that I remember that. So we have the nth root of a. And then up high turns out to be the exponent. So we could write it this way, is one useful way to write it. And that actually equals this if you want to write it this way with the m on the inside of the radical. So either way, sometimes it's useful to do one or the other. So we're going to look at this example. Let's look at this example with the 9 to the 3/2 power. This would be the same thing as the second root of 9, which is 3, raised to the top number power. So that'd be raised to the third equals 27. Now, I was able to do this all in my head because I did the root first. I made the number smaller. The second root of 9 is 3, and then I applied the cube. If you had done it this way over here, what you would have done is you would take 9 to the third power, which is a really big number, and then you would square root it. And you're still going to get 27. I believe this is 729. I'd have to go to my calculator and check. See, these big numbers are kind of annoying. So if we can do the root first, it makes our life a little easier. Right, on this example, this would be the 5th root of negative 32. That comes from this 5 right here, and that's negative 2. And then you're going to square what you have there. So the final answer is 4 on that problem. Now this would be the square root of 1/4. That comes from this number right there. That's 1/2. And then, using the top number, you cube what you have. So the final answer there would be 1/8. 1/8. I did all that without a calculator because I simply did the root first. 2 more concepts to go here. First of all, we need to review what a negative exponent does. We already know what a fraction does. We just talked about that, but we don't remember. Maybe we don't remember what a negative exponent was. In Algebra 1, you did a bunch of properties of exponents. And a to the negative 1st power is actually 1/a. It makes a fraction. And then a to the negative nth power would be 1/a to the nth power. So the exponent becomes positive when you send it into the denominator. I want you to notice it doesn't make a negative value. It's simply a fraction. A negative exponent means a fraction. So in this case here, the base gets flipped over thanks to that minus sign. Then we're going to use our root value, which is a third root. And then we're also going to square it thanks to this number up top. So then the minus sign simply flipped the base over. So this ends up being 1/3 squared, which is 1/9. Again, I did all that without my calculator. Looking at this next problem, it's important to note that this minus sign is actually not part of the base here. This is -1 times, and then we're going to flip over the base, 1/256. We're going to do the 4th root, and then we're going to cube it. So negative, the 4th root of 256 would be 4. And then we're going to cube that, and we get 64. And it's going to be negative because that minus sign was not part of any of this action here. It was way out front of the whole thing. So that's why our answer ends up being negative. And finally, on this last slide of the notes, we're going to simplify these rational expressions by rewriting them as exponents first, and then you're going to see what magic happens here. So the root is the 3. So we're going to rewrite all of these with a denominator 3. And then these exponents are going to go in the top. So 6, 9, and 1. Now what do you know about 6 over 3? Well, it's the same thing as x squared. And y to the 9 over 3 is the same thing as y to the third. Now, unfortunately, this does not simplify. So I'm going to keep it inside the radical. I'm going to do the third root of z. So z is stuck inside the radical, wasn't able to get out. So this is one way to simplify radicals. On this last problem, you're going to have a minus sign because this is an odd root. That's perfectly fine to have that minus sign. X to the 7 over 7, that's x to the first. Y to the 21 over 7, that's y to the third. And then you're going to have z to the 5 over 7. Now, unfortunately, there's just not enough of the z's to make it to 1. So we're going to have the 7th root of z to the 5th. So I'm sorry for the horrible handwriting there. I'm writing with my finger after all. Negative x to the first, y to the third, and then the 7th root of z to the 5th is the answer. All right, good luck on this section.